Today, I have a pleasure to introduce you Craig, who is head of engineering, author, and enthusiast in QA space. Before Craig will introduce his approach to CI, a quick reminder of Zebrunner as a sponsor of this event. And this is a platform that allows testing team to unify their efforts. We have QA team, we have SDT automation teams working together in a single interface. It's AI powered and it allows you video-based results for any kind of test. It's integratable with multiple automation frameworks. And there are a lot of open source versions and free versions which you can try out for yourself and see if it's working for you. So far, we've accumulated a number of great brands working with us. You can see them to the left, those we can share, and there are some bigger names. So in the end of this discussion, we will also provide you with a special discount for those who attend. I don't want to spend too much time on this, and without further ado, please meet Craig Risi.
Cool. Thank you so much, Stan. So thank you so much, and welcome to this webinar today. We're going to be talking about CI pipelines, and I think more specifically, building effective quality gates into your CI pipelines. I think everyone is moving towards this world of trying to deliver as fast as possible, but in trying to do that, there is a lot of challenges that we face because it almost seems like going as fast as possible is almost counterintuitive by trying to do things as carefully as possible. And so what we really want to try to do to talk about today is how you can really just introduce some quality gates which can ensure that you can move fast without being able to compromise on that quality of the code that you're delivering, and therefore actually putting back that confidence in your pipeline. And when your pipeline runs, you can have the full confidence in knowing it's met our needs, it's good to go, rather than feeling like, just passed the pipeline, but I need to do a couple of other checks so that you can still move fast. And that's really what I want to talk about today. But before I get further into the topic, a little bit about me. I'm the head of engineering at a company called Old Mutual Limited, and it's quite a large engineering company. There's over 900 engineers that we work with across different disciplines. So we've got to deal with a lot of different sort of pipeline challenges in terms of being able to get these over 100 different Scrum teams to be able to deploy on a regular basis. It makes it a challenge, and we are a financial services company, so we can't afford things to go wrong. So quality is important, but speed of delivery is also important. I am also a board game designer, and I own my own board game company called Risky Games. So if you like board games, please go to that site and have a look. I think I've published over 12 board games, varying different sort of genres and categories. So hope you can have some fun. And then I've also written a book called Quality by Design. So if you're ever interested in unpacking how to design software with quality in mind, I definitely recommend you give that a read. So it's not just looking about software quality from a testing angle, but also from a software angle, and making sure that you're considering everything from the beginning. And if you're trying to place the accent, I am from Cape Town, South Africa. In my opinion, the most beautiful city in the world, and all of those pictures are taken from my city. So I'm really proud, and I love being able to stay in Cape Town. So if you've never been, I'd really encourage you to visit. It is far, but it's very sunny. So you're definitely going to get some good weather, and you're going to get some good scenery. So if you like the beach and you like the mountains and you like some vineyards, please come to Cape Town. But enough of my sales pitch and my city. What we're going to get at today is really, I want to start off talking about the importance of CI/CD pipelines in software delivery. Very briefly, talk a bit about how to create a basic CI/CD pipeline. I want to just start by unpacking a bit about that complication. I understand that there might be people on this webinar who aren't very clued up in how CI/CD pipelines work. So I want to just talk a bit about that so you can get a little bit more understanding of how they work. Maybe understand a bit about the structure of a pipeline and a YAML file and why that's important. And then I'm going to get into some quality gates where you can understand what are the quality gates and why you need them, how to maybe go about building your own quality gates. And then the last part is just understanding observability in the process of being able to build uh, things in the pipeline process. But this is a typical CI/CD pipeline. So when we talk about a continuous integration or a continuous deployment pipeline, this is typically what we're talking about. We make a code change. That code change triggers that code needing to build your software. We then get to be notified of that everything was built correctly. It runs some tests, notifies us of a specific outcome, and then delivers to an environment where it can then be deployed. And that's typically what we think about when we think about CI/CD pipeline. It's that ability for us to be able to commit code changes, build those code changes, and then test and verify that that's working before we then move it on to the next stage of the journey. Um, why do we do CI/CD pipelines within software delivery? Well, that first thing is that is that faster deployment. By being able to do CI/CD pipelines, really what you're trying to do is then automate that delivery process every single time you're deploying code. You're being able to get your code tested. So your code is getting tested more frequently. It allows you to be able to therefore work quicker. It definitely improves the quality uh, of work you're doing because you're frequently testing your code all the time. Every single deployment is kind of running through and checking your code to make sure that everything's working okay. It also creates better collaboration because if you really want to do it better, and as I'll go through some of the quality gates, you'll understand a little bit more. But if you really do CI/CD properly, it means that you're going to have not just software engineers, but your quality engineers and your testers also involved in the process. So you collaborate better because as your pipeline fails, someone else will need to get involved to sometimes understand why it fails. It gets everyone working together because you need to get your pipeline to pass to be able to move forward. It builds reliability into your deployments because it ensures that what you've coded and the different code changes you've made have been able to gone through various cycles. They should be well tested. So when it deploys, it really should work because you've put it through all those levels of testing. And then it gives you rapid feedback. Because then also when you're making those changes and there's a failure, you'll know very quickly that it's failed. Uh, and you're good to go. The problem is that's all good in theory. It makes a lot of sense. I think everyone understands why we want to move towards CI/CD, and all these benefits sound good in theory. But the reality is it's a complicated space. One of the reasons why it's a complicated space is because of things like this, where there's just a myriad of tools that we've got to deal with. And we're trying to make sense of trying to build CI/CD pipelines and trying to get everything to work together. But the reality is we're working with a variety of different processes and a variety of different tools just in each different portion of our software development lifecycle. And the CI/CD process is supposed to integrate and bring everything together. And when you have a very diverse set of tools, all doing different things, that becomes really complicated to manage, and it puts a lot of pressure on your CI/CD pipelines and trying to do it right. And so it's very overwhelming. So it's supposed to make life easier, but when you have a really complicated sort of tech landscape, it can be really difficult to pull off. And this is typically how most people end up feeling about pipelines. We want to go in, we're expecting everything to go smoothly, but the reality is you're making tweaks, things aren't really working. You're spending more time just trying to fix the pipeline process than actually fix the code at hand, and you're not so sure what it is. Is the test failing? Is it an actual error? Why are we down? And we end up circumventing this whole CI/CD process and doing things manually because it's not working for us. And I think that's why many companies have, I won't say given up on CI/CD pipelines. We still use them widely, and I think every company trusts the idea behind it. But that's why we sometimes don't get the full benefit of CI/CD pipelines, and we have those additional what if steps, and having these other sort of quality steps in the background to try and ensure let's actually just check this in another environment. Let's actually have another testing process that runs somewhere else because we don't have full trust in it because of all the issues that have been experienced along the way. So hopefully we'll unpack a lot of that today and make it a lot easier to understand, how a pipeline should work. But before we go into that quality gate perspective, I want to just talk briefly about pipeline components and the different things that make up. Now, depending on the tool that you're using for your CI/CD pipeline, it might not be called exactly this. This is labeled after GitHub, which is where I've got most of my sort of personal open source projects are all running in GitHub. So I know GitHub quite well, and so I've built this on GitHub. But whether you use Azure DevOps, Jenkins, or any other sort of tools like Bitbucket, they all have various flavors of doing the same things. But essentially, you'll have a workflow, which is just something that triggers your job, an event, what must to do with it, your jobs that it actually runs, the steps that do the jobs, actions, and runners. which we'll get into more detail now. So this is essentially how it works. You have your code repository, and then an event needs to happen. So whether I've pushed code, whether I've got a pull request on my code, or maybe I've scheduled something, just to run on a regular basis, that will then go and trigger a workflow. And that workflow is essentially what does this need to do? And that workflow can pull across multiple different jobs. And so a job is essentially this particular action that needs to happen, and then that job can have a runner associated. So that runner is essentially just executing a little bit about that job. So that's actually what then takes that job and executes it against your machine. And then jobs can have multiple steps, and that can be an action or it can be a shell script or whatever it wants to be. Your workflows can't run in parallel and your jobs can't run in parallel, but you can have multiple runners to a job to help it. So your jobs can run in parallel if you set up multiple runners and allow them to do multiple things. And that's important. Your steps very much are sequential, 1, 2, 3, 4, but your runners can distribute and do things, in parallel. So it is possible to, within a pipeline, be able to do multiple things at the same time in how you configure it. But this is at high level how it works, and what you can expect. Um, and then you'll hear the phrase YAML file. So I'll go through a little bit more detail about YAML files in more detail, and maybe show you, if we have time, I'll show you actual some YAML files and how to look. But YAML is very important because in all these tools, you can configure your pipelines manually, and you can go and you can say, I want to follow the steps. So there is manual steps to do, but I think just like with automation and manual testing versus automated testing, it's better if you automate it. And by being able to write a YAML workflow and be able to use YAML commands, um, it helps to then be able to build out your pipeline by calling different steps, like you see on the right hand side, where I call different things. I call certain workflows, and that's when I actually tell it what to do. And by being able to understand that YAML workflow and be able to put that in place, that really helps to be able to put something in code. And that means that it's reproducible. So you're not just creating something within a tool, but because it's in your code, no matter where your code sits, your pipeline will always be able to run and execute because it's reading your pipeline from that file. And with YAML, whether you're using Azure DevOps or GitHub, it can look for, oh, there's a YAML file there, read it, put it out, and it knows what to do with it. And if you store it in the right location for that particular tool, it'll automatically build your pipeline for you. And that's the benefit of doing it in code. It really makes it a lot more configurable. So it's important, if you really want to understand CI/CD pipelines and get to play with them and build quality gates, to get into YAML and understand YAML. So I put a reference there just to a cheat sheet if you want to learn a bit more about YAML. But like I said, if we have a lot of time, I'll maybe go through a little bit more detail about it. But it's quite readable, if you can see on the right hand side. And we'll unpack some of the different things that you'll get into YAML now. So coming back to some of those different elements of a CI/CD pipeline, like I said, those are events. And so events is really, if I want to schedule a pipeline, say, I want to schedule a pipeline to run overnight, that would be an event that would trigger something. If I'm doing a pull request, if I'm pushing code into a pipeline, that can be a trigger. They can be, sort of at repository dispatch or even an issue. Sometimes even just an issue being logged against your system can cause an event. So you can put certain rules in place to be able to say, because of this happened, I'm going to trigger this workflow. So that event is that thing that happens. And in your YAML code, you'll simply say something like this. You'll say on. And the reason for the on command is because you can switch certain steps on and off. And that's the nice thing about YAML as well. Again, you can switch things on if you need to. You can always edit it. And rather than changing your process, you just switch it off, but you say it's on. And this repository dispatch by default will just say, okay, this is this type of event that I want triggered. Yeah, we see at the bottom there is something saying on at a schedule, and then using this cron job, I'm actually specifying the time of day that I want this to run, and how frequently I want it to run, and then to that schedule it will then run in more detail. Uh, then the same with events, they can have different types. And so, for instance, let's take the event of a pull request. If I want to have a pull request, it can be assigned, it can be opened or closed. What type of pull request? So when my pull request changes to a certain type, it must do something. So you have an event, but you can also assign a type to it. And on that right hand side, I put an example of issues. Like these are the types of different things that you can get. And there's a lot more than this, and it differs based on the tool that you use. But if you're using issues as an event, uh, you know, again, you're saying if an issue has been opened, do this. So you can automatically go to your code and say, okay, when this happens, and then the moment something happens and something gets logged with a particular tool and it's read it, and now your pipeline tool has picked up that this issue has changed, you can then tell it what to do and how it can start to automate your processes. So again, making the developers' jobs easier and automating that process of what they're trying to do. Um, uh, you can also then specify branches. So one of the beautiful things about CI/CD pipelines is that it doesn't have to just run on anything. You can actually tell it what to run against what. So well, if you want to run a particular pipeline just on a particular feature that you're working on, you can specify just if this change just occurs on this feature branch, just run that. But on your main branch, you might want to run a lot more comprehensive set of tests. So it allows you to set up a proper branching strategy so that you can get that immediate feedback. You don't want to make slight coding changes on a small feature, and that's going to run through the entirety of your CI/CD process on your main branch. It's not necessary. You're just doing a small piece. So you would typically create something just for your branches, and then when you deploy into that branch, it knows, okay, well, I've just made these changes. I'm just going to run these small tests. It gives the developer fast feedback so that they don't need to wait for your entire pipeline to run to get a result. And let's say your pipeline runs 10, 15 minutes before deployment. That's a long time to wait to know if something failed. Rather run it, and that's just that small feature. It runs your unit test, and very quickly they get feedback to say something failed. And then you only run against your main branch or your release branch, however you set it up, or your feature branch, when you really need to, once it's gone through several layers. So again, that's the beauty of events, that we can also add branches to it, and we have that level of customizability, which is quite useful. Within jobs, so again, you now have your event that triggers a workflow. Within that workflow is now a set of jobs. So here is an example of some jobs that you want to do. Uh, every job has to contain a unique ID. So in your file, you can't have jobs. So we've got job one, job two. I can't label this job one again. It'll cause an error. It won't be able to compile properly. Your like YAML file requires that every job is independently called. You can set here this run on command where you can tell it what type of machine to run on. So essentially, uh, when we went back to that model earlier on, where you essentially have your runner, this is basically what I'm telling it. I'm telling it to set up a runner and spin up this. So essentially, I'm saying I need this to run on an Ubuntu latest machine. So kind of like how you would work with Docker containers. Normally, when you're working with your CI/CD tooling, you will specify which runner you want to work with. In GitHub, for instance, that's just something which GitHub will manage. You just tell it what to do; it will automatically run those jobs for you. It will spin up a quick runner and be able to do that. If you're using a zero DevOps, um, it's it has its own sort of build agents, and so you would then specify the build agents and then label which build agent you want to use, and it will be able to spin that up and run that for you. And then you just simply tell it what to do. And so, uh, like I showed you earlier, it is possible to run your jobs in parallel, but your steps can only run sequentially, but you can have multiple steps within the process. So if you need to run and you need to run a job that's dependent on another job, that's important to note that it can run in parallel. So if you ever need to run something and then it needs to actually wait for something to finish, you need to put in that needs command to say, actually, this needs the other job to finish. Please don't run. So you've also got to tell it not to run in parallel. By default, it will run in parallel. So you've got to just specify those type of things. So, um, and then your steps. Your steps are quite basic. Like I said, they're dependent on each other by default, and they will always execute in order. Step one, step two, step three. You can't circumvent that and put in logic. There's no logic flow that comes into your pipeline process. Your YAML code is very simple and straightforward. But you can share data between your steps. So if you call something step one and you're using a username, you can extract that username and put it in there. That's important to note because that won't work if I were to go back to my job and there's calling data. That data might not be able to always be easily transferred across, particularly with your different workflows, your jobs. So it's important to understand where your data flows and what data can speak uh, to what. So because your data can be shared between steps, if you that if you're pulling and extracting data from that step, you can use it elsewhere, but you can't always do it in other jobs that need to run in parallel. You actually need to set up your data separately in that particular steps, and then you have actions, and that's just simply what are you doing. So In GitHub, this is an example of just actions and how you would do it, but you're basically just telling it to do something. So it's really just the detail of what that step is going to do. Um, so yeah, I've gone through that very quickly. Last thing is also just some things around your runners. So runners, you get three really different types of runners, and again, I'm using GitHub as an example, but that GitHub can really be replaced with any tool there. It's a machine where the workflow is executed, so you can choose to execute on your own local machine. So you can tell a pipeline to execute on your local machine. You can tell it to execute on, in this case, GitHub, or if you're using another tool on that particular tool's default agents. So GitHub, because it runs in the cloud, it has its own, it has a set of GitHub managed runners that you can utilize. Microsoft does the same with some of their Azure DevOps. They have some default stuff that you can leverage. But often, in most organizations, you want to use a self-hosted runner. You want to actually go and create something yourself, and then be able to set up an actual machine that's set up for your workplace with your security permissions. So most organizations will use a self-hosted runner, and then you simply just pull the runner that you need. Um, it You don't always need to have a clean instance either, because if you're using the default GitHub stuff, it'll always start from scratch, and then you might need to run some commands to set it up. If you're using a self-hosted runner, your organization can set it up to the level where it always needs to be there, and you don't need to have a clean clean instance all the time. So that's just an example of runners and how they would work within a basic sort of pipeline. So, like I said, I'm trying to go through that quite quickly. That is a lot of detail, but for those that aren't familiar with the idea of CI/CD pipelines, hopefully that's given you a little bit more of a foundation in terms of how they work, why we use them, and if you want to start exploring them more, you can stand by understanding that logic. You'll get to be able to contribute a little bit more to that space. But I want to talk about quality gates because I think that's why we're here. So, what is a quality gate? And I like to think of a quality gate really as a change control, but really more of your entry and exit criteria. We used to always think about entry criteria to test, and then how do I know that this is ready to move on to the next phase? And that's essentially what we're doing from a quality gate. It's really just a check to say, I have now looked at this particular part of the process, and I have determined that it's good enough to move on to the next part of the process. So making sure that in those individual steps that we mentioned within our pipeline, or those individual jobs, that we're doing checks in between those jobs, or so that within that workflow there's multiple checks to say that I'm happy for this to pass to the next phase of this workflow. So before I call this next job, I need to make sure that this first job is not just run successfully, but that I'm happy with the software output that I've gotten. So I've good enough quality, and that's what you want to do, and that's the benefit of this. And it really just prevents later issues being caused by you deploying bad code into environment by going through rigorous testing processes. And it can be automated. And that's the nice thing about the quality gate is you can easily automate these into a CI/CD pipeline to be able to give you better confidence throughout the stage. Why we measure, we can measure to automatically ensure that we have acceptance criteria met. Again, we're not producing bad code further down the line, but we can do these things quickly, and it ensures that this piece of code is really what we need, and then we can move on. It drives that shift left mindset that moves everything to the left. In order to do quality gates or CI/CD pipelines properly with quality gates, you really need to have that shift left mentality. You've got to make sure if you're writing code changes that there needs to be something there to verify your quality. So it forces you to think about, am I going to unit test this? Is my unit test coverage going to be decent enough? Because if it's not, what's the point of the quality gate? So it forces you to think about, how do I shift my test and automation more to the left so that I'm not leaving too much quality control for outside the pipelines, but that I can put everything into a pipeline process. It safeguards against poor quality code. In later cycles, a lot of software testers or quality engineers can relate to getting code that gets deployed into environment and basic things feel like they're not working. This kind of prevents anything being deployed into an environment that's not fit for purpose. Um, it then prevents testing being impacted later in the cycle, and it ensures proactive quality, which is really one of the key things that we're trying to drive here. um, but it sounds great. These are the things we want to do. But then what are some of the building blocks that we need for quality gate? So we've spoken about CI/CD pipelines, but it's not just about sorry, it's not just about yeah, implementing with them. You also need to have a bit of a culture change to be able to really work with quality gates. And the first thing is you need to have really well defined and clear. Sorry, I'm going to get some water. Just hold on.
Absolutely. Bless you, Craig.
Thank
Guys,
you.
what do you think so far? Are there any questions by now? We'll have a Q&A session later, but maybe you'd like to clarify something.
Oh, sorry about that. My throat was getting dry then, of course.
Absolutely. No worries.
Great. Do you want me to continue or do you want me to take a question?
I feel like we can put off the questions till the end for now.
Okay, great. Thanks. But yeah, there are some culture changes that you need to make. Like I said, so the first is that you've got to really have well-defined and clear completion criteria. So you need to know what good enough looks like. So if you have a step in your process, what does good actually look like? And it needs to be very clear and well defined. And if you don't have that, you obviously can't build a quality gate. If you don't know what good looks like, if your tests run, you know, do all the tests need to run? Do just a certain set of tests run? If it's not very clear, it's very difficult to measure. So you need to have that in place. You need to have a testable architecture. And if you have software that's very difficult to write unit tests for, or to be able to get into the APIs and easily automate at an API layer or at a very small layer, it becomes really difficult to be able to, to do CI/CD pipelines effectively with quality gates. There needs to be a strong focus on unit testing because of that early feedback you want from developers. There's no point pushing things too late before things are tested. You want to get that testing done straight away. So you need to have a very strong focus on unit testing to get that right. And then even your later integration test that your QEs and your testers would normally get involved in, that needs to be automated. So if you're still using very manual processes somewhere along the line, it's going to become very difficult to put into a CI/CD pipeline because you need to automate that. And it works best for small, frequent releases. CI/CD pipeline is not designed for we're going to deploy the software once every 3 months or once a month. It's really designed for we've made a code change. Is it good enough to go to prod? It really works best in that type of frame. So if you're an organization that really wants to only deploy once every couple of months or once a month, and you're going to battle to get the real value out of this. So it's really for those companies that are willing to deploy frequently that you're going to get the value out of a CI/CD pipeline, and in particularly building that in. So what is a quality gate check? It's quite an extensive list, but this is just a few things that you can use. And I apologize, security scans has appeared here multiple times. Um, but it's essentially it can check things like your build health, your infrastructure health. So build health, did it build okay? Your infrastructure health, is your test environment itself actually healthy? What are the test results? Let's have a look at that. Is there code coverage? Do they have stuff? Have we got security scans? Have they run? And those are the type of things that you would typically want to check within your quality gates. Um, and Here's some types of quality gates that you can get. So you can run a quality gate at the setup and checkup phase. So when you're just setting up your your machine to build or your code to build and just checking out your code, you can already have a quality gate just at that checkout phase of your code to be able to check things. You can then have a quality gate to check the build of your code. So your code built, but was there a problem in the build process? Were there any issues that were picked up while it was building on its container? You know, how do you verify that everything's working okay? Then you're executing your unit or your CI tests. So you're actually having unit tests that are running on your thing, or you might have additional tests that are running in your CI pipeline that you then want to check. Has it run? Have they passed successfully? Um, Running a static analysis scan on your code to see if any issues are picked up. Having a look at that, and then being able to do an environment readiness check to say, well, okay, well, I've passed this whole cycle. Now you can have another quality gate to say, well, actually, now I need to go check. I need to now move this code from from this branch into my development environment or my test environment. But is my test environment actually in a state where things are up. There's no point trying to attempt a deployment into a broken environment. So you can actually go and check to make sure my environment is ready there. And if you've got contract tests in place, this is the time when you'd call your contract test to say, I'm moving into this environment, but hang on, some dependencies that I need are not here yet. Let me not deploy it because this code will fall over because my dependencies aren't there. So you can also put some contract tests in place and test that the environment is in a position where you can get a good, reliable result. There's no point deploying code into environment where its dependencies aren't there, and then you're wondering, oh no, but our pipeline failed, the tests are failing, what's wrong with our code? Meanwhile, your code is fine, you're just missing a dependency. You can do all of that check before you even make the deployments. Then you can do again your like pre-deployment and your post-deployment checks. So you can check before you deploy and your post. You check these things. You can then run further sort of integration testing, and then you can do the dynamic code analysis if you want for those doing mutation testing or other sort of things. You can put all that in, and then even non-functional testing. You can even run performance and security tests in your pipelines, and that's something as well which I'd recommend you trying to do so that the moment there's any sort of degradation, you pick up on that. Examples of some of the quality checks that you would typically want to look at. So, for instance, if you're building your code, you're checking it out, things like your linting standards. Your organization probably has a whole bunch of coding standards they want to adhere to. You can put those linting standards in, and you can run a check, and it can fail literally when a developer is trying to push code into a branch and say, this doesn't match our coding standards. Sorry, you need to fix that before we even go any further. So again, you can do things like that. You can have a quality gate of 100% successful completion of all tests. So you're saying, I want you to run your unit tests, but I want 90% of your code coverage to be achieved. So I don't just want all of your unit tests to pass, because you can just have one unit test and it passes, but that unit test doesn't cover anything. I want to say that that's 90% of everything, and so you can have that. Uh, but then you also want to have a successful maybe completion of of your security scan. So your security scan runs the code, and it can run through 100% of all your code and come back green and say, I picked up no new security issues. Your code is good to go. And so that's again something you want to build into, and then you'd obviously want to check something. A simple one would be any sort of automated checks that your quality engineers or testers have written. Have they passed as well? And if there's any failures, you can again choose to block the build or fail the build depending on the that you put in place. But that's an example build. But you don't have to just do the code pipelines. Obviously, we're talking about CI/CD pipelines, but here's an example of some quality gates that you can even do. Even from an analysis perspective, you can build in your pipeline to actually check, is my analysis done properly? So you can, within your pipeline, say, before I trigger the code, does this Jira story exist, and does the Jira story actually in the right phase? So I've triggered this code, my developers pushed the code, but the actual analysis work from the BA is not even finished, and so they're like Jira tickets in the wrong status. You can actually check that and validate. Go to Jira, call an API, and say, is this in the correct status, and is everything there? And you can check all that type of stuff. And so, again, we can even think outside the pipeline and outside of our code process. You can build all of that in. We can do things like then your like code deployments while you're writing your code. There's things you can do. Then when you want to merge it, run some tests. You can want to work within a different sort of branch. You can run some more tests. And then you want to build and install, and then you want to put it on some sort of big test environment. You can run some more tests. And again, we can carry on all the way up to a point where you can now even go into production. And then when there's issues and incidents, you can have a quality gate for an incident's been logged in a pipeline that runs on that with certain sort of quality gates. So there's a variety of things that you can build within that, and you don't need to always be thinking about your same traditional development cycles. Here's an example of some things, and so if you want to check an environment before and after deployment, here's an example of something that you easily put together your pre-deployment test, where you really just have this is something that I want to run. This is a task, my job, and I've just got some bash scripts that run. They can check. So I can write some bash scripts, or I can do some pings if you've got some APIs that you want to run, or if you've got something in the cloud, AWS and you know Microsoft and Google, they all have the ability to be able to send a message to the service and to get it back to you from a test perspective to check if something's up. So you can just run that command, and if that command is there, or again, if you've got your contract test, here's where you would run a contract test to say, eh, you know, does this API exist and does it have the field I need it? Yes. Okay, great. I'm good. It's of the right version. I can work with that because everything's there. And so again, that helps. And then your post deployment test would then be once I've deployed, what do I need to run? In this example, I've just got a basic bash script, but you can essentially just replace this with any sort of automation script that you've got. Once the code checks out and you've now deployed, you simply just go and you check out and you can just run whatever script you need to execute your automation. You can put that there. Here's an example of one with code coverage where you basically I've got some code, I'm building my code, I'm using Cobature as a code coverage tool after the code's been built, and this is just basically telling the XML where I've basically just set it up and where the results going to be stored. But I'm setting here a code coverage target of 90%. So I'm saying that my unit tests need to run, but I need to make sure that 90% of my code is covered when this runs. And um, uh, I'm setting that to 90, and then I can set that to fail if it doesn't get hit. It's an example of something you can do. And then here's an example of how you can set up a successful scan. So here on the right hand side is just some of the setup of how that would look from a YAML perspective, setting up an Aqua scan and some of the setup on the environment and some usernames and passwords and things I need. But the real meat of it's on that left-hand side where I've now got my package policies and I want to say that if something is not compliant, it's false. And these are the like different values where you get your critical, high, medium, low that you can set up on your on your scan, but then you can actually then within your pipeline and within your YAML code actually say, but the violating severities is only critical, high, and unknown. So if I get any of those three, I want to worry about it. Otherwise, if not, um, it's not accepted. That's a violating thing, and then I can check if it's safe. It fails if it contains any violating properties, and then you can give it a rating. Otherwise, it doesn't fail, and it's safe to go. And so you can then just continue on. So again, you have the freedom and flexibility within your within your quality gate to decide and determine what it is that you want to do and what you want to allow through, which I think is very useful. Um, I will finish off next couple of slides, but then I can also go through an actual example. I've got my GitHub app, so I can actually take you through some working examples of how this will look. But if you want to do best practice for CI/CD to pipeline, and this applies to your quality gates as well, the whole idea of starting small and iterating comes into play. So don't go big bang with your massive pipelines and build 9, 10 quality gates all in one. Or if you're trying to start small, just start with one small step of your CI/CD process, put a quality gate in there, check it, make sure it works. Once you know that's reliable, move on to the next step, and you continue that, and you continue to implement those sort of deployment practices slowly. Get that feedback loop of this first one's now working and we trust it. Then I put the second one in place. That helps you, so you don't rush into that. You want to make sure that you've considered your security, that you've got the right scans in place, and are your scans actually thorough enough uh, to scan everything. That's why sometimes that scan coverage of 100% is important. I've seen many organizations use a tool for security scanning, but then their libraries are out of date or it doesn't support one of their programming languages. Consider all those things and put that in place. You've got to have that strong focus on automation. Make sure that's there, and everything needs to be version controlled. And the beauty of having YAML files and your quality gates that you can version control and switch things on and off as well, so that you can again against certain versions of code you can trigger different workflows and different pipelines that can help you to be able to achieve and run things. So if you know you're on a certain version of code, run this with this quality gate, but this version run this with this quality gate. So there's a lot that you can do. It really provides you with that flexibility to test as much as what you want, and a lot of it's all automatable. Um, so really useful. I wanted to just lastly just talk a bit about observability, because observability is very important in the process of building quality gates, software development in general, but just in quality gates as well. And your CI/CD pipelines is observe what goes on. You need to have some form of observability. Don't just see, oh, my pipeline ran or it failed, but be able to put some reports, push it into a place where you can start to collect your data from your different you know pipelines that are coming through and all the failures, to start picking up things so that you can look and be able to see, okay, these are the things that are failing. This is our pipelines are slow because of this reason. Our pipelines are failing their quality gates because of this reason. It gives you more ability to be able to adapt and adjust your quality gate. Sometimes you may be too strict. You want to achieve well, but as you unpack, you realize you're failing too many times, and maybe it's because you're not at that maturity phase yet. Maybe you soften a quality gate to allow that that ability to deliver faster should that be important to you. And you have that flexibility to change it, but you can't do that without fully understanding your quality gates and what's going on, particularly if you get a lot of failures and you're thinking it's a test failure when it's a code issue. Um, uh, it's being able to then identify and have that visibility of what's going on in your code and in your environment at the same time. So make sure that you have observability set up, make sure that you have alerting set up so that you can respond accordingly when certain failures occur within your pipelines, and that you're constantly optimizing. And then you're getting rid of your data. So that part of just keeping track of data retention policies is your pipelines, because they run so frequently. What you don't want to do is gather copious amounts of data, and then things fall over. And this is an example of just some things that you can run. You know, upload out all the data of what you'd get. But this is a Grafana report where you can check your pipeline runs, what's passing and failing. Your average duration of a pipeline is 22 minutes. This is your pass ratio that you're generally getting, and then you can start to pick up trends of maybe when your pipeline is doing well and not doing well. So again, understand how your pipelines perform is a good way of understanding how your software will perform. Maybe your pipeline is running and failing more regularly, but there's another job that's executing all that time during this phase. Or when I run these two pipelines, or when I'm running my performance tests, my pipelines, start to pick up certain behaviors in your pipeline process. It's good to understand that, so that you don't just have your quality gates there, but you can also understand what's going on with your pipelines in more detail and modify and build new quality gates as you understand where sometimes everything passes, and but then it fails in production, but you go through and check and you realize your quality gate actually missed something along the way. You can refine your quality gate to better improve it. So that refinement process um, is really important. So I've come to the end, but before I go to questions, I wanted to just actually unpack something, and so I'm going to just um, showcase my browser here. And so there we go. So here's an example of stuff. So I've got a GitHub repo um, that I've put together. And this GitHub repo, by the way, anyone's welcome to go. Craig Risi AG. You can find this here. I've got a quality gates end-to-end repo that I've set up. You're welcome to go check that out and see an example of how to set this up. But this is just YAML how it works. How I have an end-to-end pipeline. I have got to deploy and test, and this is from me. So when I'm running it, I've actually got to go and check that who ran it, so I can actually then go and report on who ran that test, and then that's what the run name is. This is a workflow dispatch, so I will deploy this when my entire workflow gets pulled. So I'll manually deploy this when I want to, and it can then go and run things. So it will run. I'm checking out the latest Ubuntu, but I'm setting something on Java 11, so I'm setting up my JDK 11. The difference of distribution things that I'm running Maven, and then I'm going to be running some unit tests. So I'm using Jacoco as a plugin to run unit tests. Get there, and I'm going to set it up that I want my code coverage to be 0.8. So I'm literally there setting I want 80%. So that's something as well that I can do and that I can set up. So I'm using that as a way to be able to check my unit test and ensure that I want to do it. I'm not running branches, so everything here is kind of just running on a production environment with this particular example. But then I've actually got steps, and then I can actually go in and check what it wants to do. So I have my security keys to be able to run against the cloud in my environment, set up Tomcat, and then be able to do something. I've got a sleep command where I've got my bash script running, uh, but then I have that in place, and then I can go uh, again now analyze something. So I'm going to analyze, check that everything's okay, and then I have steps to be able to build my code. But what I really want to just get to is now, again, I'm coming through some things and I have steps here to be able to run some commands and do some cleanups, and then come through. And then I want to run some end-to-end tests. So I can now go run end-to-end tests, and I need to trigger and make sure that everything runs okay. And so I've put those steps in place. So I can build quality gates here to basically say that if it fails and I'm not happy with it, these are things that I can do. So it's an example of things that you can do. So for code coverage, like I said, there's something as well, like another one where I've got Gradle, where I've just set it to 80%. And then I've actually literally saying it's below 80%, I'm failing the build. I send a message out. So there's things that you can do and pay that. Here's one where I have a linter. This is just a few small steps where I was playing around and I built a quality gate just for a linter. So I installed the linter. I'm telling what type of linter I wanted it to use, and it just simply checks, and then it can actually add a ticket ID, so that when it fails with an error message, so the developer gets a command to say this has failed, you need to fix it, and actually goes and sends them something. And this is on a pull request. So whenever something's opened, edited, reopened, synchronized, um, I've got stuff there. And then I've got one here, which is a code QL one, which is a security scan where I've actually gone and run some stuff and just put some in through there where I can actually go and perform a code QL analysis and I schedule this one. So it's a static scan that needs to run. And I have set up the fail fast as false. That means if it fails, it will continue to run. It's not going to send me failures. I've just done that personally so I don't get emails every time it fails when it runs a scan because it's not a, but like typically you would say maybe you'd want to set that to true so that when it fails, send out to pass, and then I can choose what branches I want it to run and when I want it to run. This is an example of things that you can do within it. It's again, if you have all your tests written and you have everything in place, that's really where the meat of it is. And your quality gates are actually relatively easy to inject within a pipeline. So it's very important to understand how a pipeline works, how your CI/CD pipeline should be structured, and then you simply got to just inject the right steps in place to put those quality gates and allow you to be able to put everything in order. Great. Um, let's move back to Q&A. Any questions?
Thank you so much, Craig. Just to double check, we also have, as promised, for those of you who have had patience and interest and spent some time with us, we also have a special discount. So if you could, yep, thank you so much, Craig. So for those of you who have registered to this webinar with Craig, we suggest you a special price for both of our major products, testing platform, which includes test case management and automation reporting, which is specifically dedicated to those teams that are looking into results of their tests. It's video based, it's connecting with any sort of automation framework that you use. Just check it out. There is a trial period for 2 weeks and we can extend it if you need it. So keep in mind those options. And to the topic that we've raised today, CI, we also have add-on, which is responsible for executing tests in parallel. And we can run up to 1,000 and even more threads in parallel, effectively saving you time to see the feedback, the results, and run your pipeline more efficiently. So thank you so much. And back to you, Craig, with all the questions.
Perfect. Thank you. Any questions?
I think there is one in Q&A from Nanda Kumar.
Okay.
Do you see it?
Let me just get to the Q&A. Sorry. I have my Q&A open on my Teams.
I'll post it into the chat. And guys, don't be shy. Share your questions. I'm sure there are a few.
Okay, okay for a POC type of short-lived projects, which are built in very fast manner. What kind of um, automation pipeline could be tried out? Here, the environment is very volatile and has more frequent changes. Great question, and definitely you have that. So when you have sort of like a POC type of application, um, typically what you want to do within that, you want to keep your pipeline very robust. There's no point trying to write detailed unit tests if something might be throw away. What I would typically do in a case like that, when I've got just some POC work where we just want to trial things out, I would run a security scan on that code. And if I am deploying it into an environment of some sort, I might just want to then tie it into some sort of basic sanity testing that we have. So if we have a set of environment tests before and post an environment where I want to maybe try something out and see how it works in an environment that I'm deploying to, I would put it in there. You'd obviously want to do some basic unit tests, but I wouldn't go for high coverage on a POC type item. I'd rather want to just put it out there and be able to play with things. But that security scan is one that I think is non-negotiable. What you don't want to do, and I've seen people do this when they're doing a lot of POC work, is they're utilizing new libraries and maybe trying something with a new open source package, and there might be a vulnerability somewhere along the line. You want to be able to ensure that that's in place. So yeah, hopefully that helps. Any Gen AI tools tried and experienced? I'll be honest, from a pipeline perspective, I have not tried any Gen AI tools. I do use Copilot a lot. So I use GitHub Copilot a lot to be able to help me code better. And I've used that to also help me construct pipelines. So I've used Gen AI in that capacity where I've actually asked it where, I need to do something. and then I actually ask it to. We spoke about earlier on, like I had that slide of all those tools, and I'm sometimes not so sure how to configure to a tool, and sometimes it can help you solve some of that. But you're like, you want to add a step onto your pipeline process to achieve this, and you want to put a quality gate in place. It can sometimes help solve that gap for you. So I've, I have utilized tools like that, but no Gen AI tools specifically built around that sort of CI/CD process and that testing process. But that's just used for my own coding benefits. And uh, there, you can also, technically speaking, use it for visual tests. I have run AI visual test. It wasn't really Gen AI though, but it was an AI visual test against some front end code where the AI then goes and renders it. Instead of using a device fob, which can be quite slow and problematic, um, it's and slow down your pipeline. You want to get a quick result. You can use some AI tools for visual testing, um, which which are quite useful. Like Aptly Tools is one of them that I've used, where you can go, you can set it up. You obviously have your license. You configure it to go, and then it will go and deploy your web screens or your mobile screens that you've developed and be able to render that and utilizing AI. It renders it in multiple different ways and runs some visual tests for you to verify how it works and looks. And I found that to be quite useful as well. It's not really Gen AI. That's just some form of AI me telling it what to do. But hopefully that helps answers your question.
Guys, are there any other questions at this time? Because I understand that it's food for thought and you might need some time to process all
Yeah,
this excellent advice from Craig. Thank you so much,
yeah.
Craig.
No, it's a
Uh,
pleasure. And I know I went through it quite quickly, but I was just trying to get the basics right because I feel like if we don't cover things, it's going to be really difficult to understand some of the code. But please go in and go in, explore things, go to my GitHub repos, play with some pipelines there. It will help you to hopefully unpack. I see another question. Collaborative approaches between engineering and DevOps teams are required. Who remains accountable, engineering or DevOps? Great question, and I would say both. I think ultimately, if I'm a engineer and I write my code, I'm accountable for that code, and I want to make sure that my code is of a high standard as possible. Making sure that the quality gates are in place is often a combination between the DevOps engineer who might know a little bit more around some of the environment configuration, some of those pipeline skills that they might have, and they have deeper knowledge and maybe moving things along. And they might also have access to your security scans that you might not, that the whole team might not have. But you then need to collaborate with them, but then you also need to collaborate with your quality engineers or your testers to make sure that their tests are in the place. And then there might be an architect that's needed if you're not so sure how to build something. Is it testable enough? I would definitely try and bring that collaboration. But to me, really, the whole team's accountable. As a software engineer, I want to make sure my code passes, and it's my responsibility to fix and get that pipeline green. But ensuring that we've got the right quality gates in place and that we can build that trust in the pipeline process, I believe the whole team should work together on this and utilize their different skill sets to make it work.
Thank you so much, Craig. So just to reiterate, guys, if you will be having more questions, feel free to send them to Zebrunner directly. We will also be posting this video in our channel on LinkedIn soon, and if you will have more questions, we will kindly ask Craig to share his advice on those if you will have some time, of course.
Absolutely, always a pleasure.
Thank you so much for your time, Craig. It was an excellent conversation, and I hope there were a few takeaways that guys will be able to improve in their existing pipelines already, starting from now. Perhaps after their team will also be seeing this one. And really appreciate your time today, and looking forward to continue this conversation in online.
Thank you so much. And thank you for having me. Really appreciate it. Thanks,
Bye,
everyone.
everyone. Now.
Keep well.